Hello everyone, welcome to a tutorial on transformations to curves. So there are four basic transformations to curves, and these can be split into two categories, adding and multiplying. Now, excuse that. So in adding, you have two kinds of transformation. One is of the form fx plus a, and the other is f of x plus a. And this is all acting on the parent function f of x. So if this is the parent function, there are two possible transformations you can apply by adding a constant a. One is if you add a to the inside, which is make it f of x plus a, and the second transformation is if you add a to the outside, which makes it f of x plus a. So let's see how these two transformations affect graphs. Now, for both of these, I'll be using the graph fx is equal to x squared. This is what that graph looks like. Okay. So now for the first one, if you want to sketch the graph of f of x plus 2 whole square, this is nothing but f of x plus a, where a is 2. So what's going to happen to this graph? This graph is going to move to the left by 2 units, because whenever there's a plus a, that always leads to the graph moving in a minus a direction. And if it's a minus a, it'll lead to the graph moving in a plus a direction. And this is only horizontal movement. There's no vertical movement involved with just this transformation. So what will the transformed graph look like? It'll look something like this. That is, it has moved 2 units to the left. So what was originally 0, 0 has now become minus 2, 0. So that's one transformation. Now the other transformation is f of x plus a. So with the same parent function, which is f of x is equal to x squared, we want to find out f of x squared plus 2. And for this function, adding an a will either move the graph up if a is positive, or move the graph down if a is negative. There's no horizontal movement, there's just vertical movement when the a is added to the outside of the function. So what will this transformation look like? It will look like this, where if this was originally 0, 0, that point would be 0, 2. So hopefully you understood that. And just recapping, if this was minus 2, the graph would move 2 units in the plus direction. If this was minus 2, the graph would move 2 units in the negative y direction. Plus x, I'm sorry. Okay, so that's it for adding. Now we come to multiplying. So for multiplying, it would be better if I use a different graph rather than a f of x is equal to x squared graph. So I use the f of x is equal to cos x graph, okay, for this one. So this is what a cosine graph looks like. Hopefully you know that already. And suppose now we're gonna multiply the function by something, which is we're gonna multiply the x by a constant a. So it's f of ax. So let's take an example. If fx is equal to cos x, what is f of 2x? F of 2x is nothing but cos 2x, right? Because you're adjusting the x value here. And what this does is, this is basically a horizontal stretch of scale factor 1 by a. So what does this mean? This means that all the x coordinates are multiplied by 1 by a, and the y coordinates are left you don't do anything to the y coordinates. It's basically squashed up in a horizontal direction. So if it was here, a is 2, right? So this graph is going to be squashed up by a scale factor of 2. Got it? If it was cos half x, this graph would be enlarged by a scale factor of 2. So it's always by a scale factor of 1 by a in the x direction. So I drew it under just to show you, just to outline how it becomes smaller, but actually it's gonna reach the same limit out here. There will be no stretching in the vertical direction. So realistically, it would just be something like that, and out here something like that. Okay, so hopefully that isn't too messy and you understood all of that. If not, just remember, when it's multiplied by a, something like this becomes something like this. It's multiplied by 1 by a, something like this becomes something like this. Okay? Next we have the second type of multiplication is when the a is outside. So it's a into f of x. So let's take another example. F of x is sine x. What does 2f of x look like? 2f of x is nothing but 2 sine x. So there's a big difference between f of 2x and 2fx. In f of 2x, you're changing the x value. In 2fx, you're multiplying the whole thing by 2. Okay? So with transformations in the form of afx, it's nothing but a vertical stretch of scale factor a. What this means is that all the y coordinates are multiplied by a, but the x coordinates are left unchanged. It's basically stretched upwards in a vertical direction. So what would this graph look like? This graph would become something like this. I know it's not the best material, probably not very clear like this, but basically what happens is it just elongates vertically, right? If I have something like this, it's going to become something like this. And if I have something, and if it's by 1 by a, if I have something like this, it's going to become something smaller, like this. But remember, there's no change to the x coordinates, there's only change to the y coordinates. And that's basically the 4 possible transformations. So of course you can have a combination of these, like you can have cos 2x plus 2, which would be nothing but the graph of cos x into a scale factor of 1 by 2 plus 2 in the vertical direction. And there are many different possibilities, and it's just a matter of figuring out which 2 or 3 transformations they are, doing them separately to get one final graph. And that's about it. Thank you.